Ever get that, like, overwhelmed feeling when you see a mountain of paperwork? Especially, when it's all filled with sensitive stuff.
Oh, yeah.
Patient names, diagnoses, the whole 9 yards.
Uh.
Well, today we're diving into a project that tackles exactly that kind of chaos. But here's the thing. It doesn't just handle it. It gets smarter because of it.
It's really a perfect example of how we can use machine learning to solve a very specific problem in healthcare.
Okay, so no abstract theories here.
No, not at all. This is about extracting patient names, from those referral letters that doctors are always sending back and forth.
Ah, those letters. So this was born out of a real need then.
Absolutely. The clinic was basically drowning in all these letters, and they were all different, different formats. No consistent way to get the important info out quickly and accurately.
Right. And accuracy is everything when you're dealing with patient data. You can't mess around with that.
You got it. And that's where traditional methods, like using regular expressions, they just fell short. They can't really deal with the messiness of human language.
Makes sense. Humans are complex.
Exactly. You need something more sophisticated, something that understands context, different writing styles. That's where NLP comes in.
Natural language processing.
Yeah.
Our hero of the day. But there's tons of NLP tools out there. ChatGPT, for example. Why not just use something like that?
That's a good point. And honestly, the team behind this project, they thought about that too. But they realized pretty quickly that, bigger isn't always better.
I feel like that's a recurring theme in tech.
For sure. Sometimes a more focused solution, something custom built using a tool like Spacy, it's just smarter, more efficient.
Spacy. Tell me more.
So think of Spacy as like the Swiss Army knife of NLP. It can do it all. Break down text, figure out the structure of sentences, and this is key for us, identify specific entities within that text, like patient names, for example. But one of the coolest things about Spacy, it's really efficient and super customizable.
So it's about precision, not just raw power.
You got it. And that's crucial when you're dealing with sensitive medical info. You need a tool that's built for medical language for the unique challenges of this particular task.
All right, so far so good. But what about data privacy? That's a big concern in healthcare.
Huge concern. But with Spacy, the data stays put. It runs locally, so nothing leaves the clinic's system.
So data privacy is baked in. Love that. Okay, I gotta be honest. I'm a little skeptical. ChatGPT gets so much hype. Can a smaller, more focused tool really outperform it?
You'd be surprised. When the team compared Spacy to some of those bigger models, it actually outperformed them in key areas, especially when it came to resources and speed.
Really?
We're talking processing these letters in under 2 seconds, even with limited computer power.
That's impressive. Okay, but let's back up a bit. Before we get to the results, how did they even build this system? I'm guessing it all starts with data, but using real patient info to train an AI is a no-go, right?
You're right. Patient privacy is paramount. So they had to get creative, and they turned to synthetic data. Fake, but realistic. They used this powerful AI called Gemini 2.0 to generate tons of, pretend medical referral letters.
Wait, so they're training an AI on fake data? How does that even work?
It's pretty clever, actually. They created these very specific prompts, instructions to make sure these fake letters looked like the real deal. Different doctor name formats, variations in patient names.
They basically built a fake medical world.
Yeah.
But isn't there a risk that those fake letters won't be, messy enough? Like real life is messy.
Oh, for sure. And they knew that. They went through rounds of refinement, tweaking the prompts, really analyzing the output to make sure it was realistic as possible. But even with the super powerful AI making the data, there was still a human element involved.
I was hoping you'd say that. What do the humans have to do?
Well, every single patient name in every single one of those fake letters, it had to be labeled by hand. So someone had to go through and meticulously mark exactly where each patient name was in the text.
Oh, wow. That sounds tedious. But I guess that's what teaches the AI what a patient name actually looks like.
Right. It's not just about algorithms and fancy AI. It's good old-fashioned human work, too. And to make sure it was all accurate, they even made a custom Python script to double-check every single label.
Wow. Talk about attention to detail. Okay, so they've got the data meticulously labeled. They've got Spacy all ready to go. What's next? This is where the training starts, right?
Exactly. This is where Spacy goes from toolkit to expert. And you know what? The process is actually a lot like teaching a student. Imagine Spacy is like this, eager student, tons of potential, but no real-world experience.
Right, like fresh out of NLP school, ready to learn.
Yeah. So you start feeling these examples, right? the referral letters with all the patient names marked up. And Spacy starts to analyze them, looking for patterns, trying to figure out, okay, what makes a patient name different from all this other medical jargon?
Like, showing a student highlighted text in a textbook and saying, figure this out.
Perfect analogy. And, well, like any student, Spacy doesn't get it perfect right away. Make some predictions, get some things wrong.
Trial and error, part of the learning process.
Exactly. Each round, it refines its understanding, builds up this internal model of what a patient name looks like, specifically in these kinds of documents.
So you mentioned epochs and loss before. Is that important for understanding how this training actually works?
Those are more like data science terms, to track progress. But the big picture is the system learns from its mistakes, gets better over time, just like practicing anything else.
No need to get too technical then. I like it.
Yeah.
So how do they know when Spacy is ready for the real world after all this training?
They test it, of course, with a totally new set of referral letters, ones it's never seen before, so they can see, did it really learn the concept or just memorize the examples?
Right, because the goal is to have it work in a real clinic, not just pass some exam.
Exactly. And you know how I said I was skeptical? Well, the results honestly blew me away. Near perfect accuracy on these new letters.
Near perfect. Like, how near are we talking?
100%.
No way. Seriously. No mistakes at all.
Not a single one. Every patient name, correctly identified every time.
That's incredible. So they basically made an AI that's better than a human at this very specific task. Starting to see why they went this route instead of just using something off the shelf. But okay, let's say I'm running this clinic. The system is trained, it aced the test. Now what? What happens in the real world?
So a new referral letter comes in, right? Maybe a PDF, a scan, even a fax, doesn't matter. First thing, the system figures out which doctor sent it.
No more squinting at handwriting or trying to decipher those letterheads.
Nope. The trained Spacy model, it just analyzes the text, picks out the doctor's name, no problem. Then it gets to the main task, extracting the patient names.
And it does this perfectly because of all that training data and those, meticulously labeled names.
Exactly. Handles all the different formats, the variations, all the quirks that would trip up a regular system.
Okay, so it's got the doctor, it's got the patient names. What next? Someone still has to type all that into the system, right?
Nope. That's the best part. The system can be designed to, automatically file that letter. Puts it in the right doctor's folder based on who it identified. No more sorting by hand. No chance for human error.
Like a super efficient digital filing clerk, working 24/7. But is that all it does? Just files things away?
That's just the start. Remember how we talked about the system learning from mistakes during training? Well, that learning, it doesn't have to stop.
Wait, are you saying this thing can keep getting smarter, even after it's up and running?
That's the beauty of machine learning. As it processes more letters, it can take all that new info, the doctor names, the patient names, the formats, and add it to the training data. So the system is constantly teaching itself, refining its understanding.
Like a student that aced the test, but keeps on studying, just getting smarter and smarter.
Exactly. Okay, but let's talk practical benefits here. What does this all mean for the clinic, in real terms? Well, for a clinic, it's a huge win. First off, think about all the time saved. No more manual data entry, no more sorting through mountains of paperwork.
Yeah, that sounds like a dream come true for any busy clinic.
It is, but it's not just about saving time, it's also about accuracy. In healthcare, a simple mistake can have big consequences.
Right. Misfiling a patient's info, getting a name wrong, that's not just inefficient, it can be dangerous.
Absolutely. This system, it takes human error out of the equation. And by freeing up staff from all those tedious tasks, they can actually focus on what matters, patient care.
So it's not about replacing people, it's about helping them do their jobs better.
Yeah.
Now, we've seen how it can extract patient names, but those referral letters, they have a lot more info in them, right?
Tons. And that's where things get really interesting. Think about it. Diagnoses, treatment histories, medications, allergies, all that stuff, it's all in there.
Wow. Imagine being able to pull all that out automatically. It would be like a game changer for doctors and nurses. No more hunting through pages and pages of text.
Exactly. With this system, all that info, boom, it's organized, accessible to everyone on the care team instantly. You could even feed it directly into the clinic's electronic medical records.
No more manual data entry, no more chance of typos or mix-ups. The system just updates the records automatically. That's amazing.
It streamlines everything. Everyone's on the same page with the most up-to-date information. And think about what that means for patient care. A doctor walks into the exam room and they've already got this complete picture of the patient's history, everything from the referral letter right there at their fingertips.
It's like giving them a superpower.
It is. They can make better decisions, give more personalized care, but that's not all. You could also train the system to recognize specific terms, concepts, so a cardiologist could have it pull out all the heart-related info, an oncologist could focus on the cancer stuff, and so on.
It's like having a team of specialized analysts working for each doctor, highlighting the most important parts of these letters.
Exactly. AI helping humans, not replacing them. And this isn't just for referral letters, discharge summaries, lab reports, insurance claims, any document with all that messy, unstructured text, it can all be streamlined.
This is blowing my mind. They basically created a blueprint for tackling any document-heavy task in healthcare. The potential impact is huge.
And it all started with this one clinic, overwhelmed with paperwork. They took this very specific problem, found the right tools, and ended up, revolutionizing things.
This deep dive has been incredible. It really shows how focusing on a specific need, with the right mix of human expertise and AI, can lead to some really amazing solutions.
And it shows how important it is to have, domain experts, the healthcare people working together with the machine learning experts. That collaboration is key to making a real impact.
Well said. So as we wrap things up, I want to leave our listeners with a thought. What tasks in your field, the things that maybe seem mundane or overly complex, could be improved, maybe even transformed with a bit of AI magic?
What's hiding in your data? What possibilities are just waiting to be unlocked?
Great question. And on that note, thanks for joining us on this deep dive into the world of AI in healthcare. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.